Welcome to today's webinar on ratios. A lot of cool stuff we can cover here. I think ratios are interesting. I've talked about this before. They're very relatable to fractions. They're very relatable to percent. So when someone says blank is what percent of blank, it's the same thing as saying blank is what ratio to blank is what fraction of blank, et cetera, et cetera. So the point is, if you have the information to cover one of those things or to deal with one of those things, you have the information to deal with the rest. The other cool thing about ratios is that they are all in terms of one kind of multiplier, right? So all you need once you have everything in the form of that multiplier is an equation. And that's super huge for data sufficiency questions for sure. For sure. So you want to get this down. You want to be able to deal with variable multipliers. We'll start off doing a pretty simple question with those, and then we'll kind of move forward from there. Let me just get this open, and then we can discuss. All right. This is a nice, simple question. See how far we get today. And see how much we can talk about, and then we'll do some Q&A at the end here. All right, so start off with this one, everybody. All right, so it looks like most of you guys got correct answers here. Did you guys use variable multipliers in the sense of saying we have lions, tigers, bears, 3x, 8x, 10x, something like that? And then basically here's your equation, right? 20 more tigers than lions, so tigers is the bigger amount, lions is the smaller amount. 5x is 20, x is 4. How many bears are in the zoo? 10 times 4 is 40. So if this were a data sufficiency question and this was given to you and the given information, and this was statement 1, well, statement 1 would be sufficient. So it's kind of nice because if you can pick up on these things, then it really just makes things pretty effortless when you see a ratio in a data sufficiency question. I'm not saying it's always going to be that simple, but in general, like if you have that stuff tucked away, then you'll be able to kind of efficiently get through a decent number of ratio data sufficiency questions. Now, there's a string of 2 questions that are in the Target Test Prep Ratios chapter. So some of you may have seen this. So you may even know the answer already. Some of you may have not. But I want to talk about these 2 different questions and how they're just slightly different and how there are different answers to each and then the reasons why. So I've done this problem in past webinars, but we'll talk about it again, and then we'll go from there. So take a stab at this, everybody. All right, so yeah, looks like a lot of you guys have probably seen this question. Now, I want to give a secondary question really quickly, and then I want to talk about the differences between the 2, almost to a point where we may not even have to write out the solution unless someone wants to see it. But this is going to be a really major point here. So I'll give you guys like a minute on this, and then we'll talk about it. But I think you're going to understand the major differences here. All right, so no, there is no recording that will be emailed. All All right, I mean, you guys know the deal here, most of you, and we can go through solutions if you need to. Does anyone want to tell me why this one is C and why this one is E? I mean, I do know we've covered this a number of times, but I just want to see what everybody has to say about that. Yeah, so we're using multiplication in this one, whereas in the other one, we are not. We are using some sort of addition. Does everybody see that okay? All right, cool. Now you realize this carries over to a lot of stuff, right? And I'm sure you guys have seen stuff like this on various questions. Like if this problem was asking about percent greater, for example, what the revenue from red wine was what percent greater than the revenue from white wine, then it would be the same concept. So my point is, and I'll say this till I'm blue in the face, if you can get this down and understand how these things work, how you get a ratio, how you don't, how you get a percentage, how you don't, you're going to crush these questions. Now, someone asked about the answer choices. These are data efficiency questions. So for everybody here, I'm always going to make the assumption that you have the data efficiency choices memorized, A through E, and that's why I don't put them there. So yes, these are data efficiency questions. Another important part of ratios is when you have a three-part ratio. That's another big thing, and this is a big thing that you can see in data efficiency and in problem solving alike. So I want to do one of these question types as well. So take a stab at this here. All right, so I see some answers coming in. All right, so we have red to green, right? Which is 5 to 6. And we have, sorry, red to blue. And then we have red to green is 4 to 3, right? Now the problem is you can't have red being 5 and red being 4. So really what this is saying is it's got to be 20 to 24 and 20 to 15, right? Now, that gives us a 3-part ratio of 20 to 24 to 15. And we could assign an X multiplier to those if you want to. So that's 20X. We could say 20X to 24X to 15X. Now, the thing is, when X is 1, we have ourselves a 2-digit number. The problem is, okay, when X is 1, we have 20 plus 24 plus 15. So that's going to give us 44. That's going to give us a grand total of 59, right? Problem is, when X is 2, it goes above being a 2-digit number, which is why 24 is the correct answer. Now, if for whatever reason it said the number of total worms in the box is less than 150 worms or something like that, then all of a sudden the answer to this question is C, 48, as opposed to 24. So the point here is watch out for the restrictive information that allows you to come up with something specific. And, you know, that way you're in a position where you feel like you'll be able to answer the question. And in data efficiency, especially look out for those things, because if you don't, you know, your answer choice and data efficiency could be somewhat off base. So hopefully this is a seemingly simple problem for everybody. It seems like you guys are doing well with these today. My guess is that you feel like you have a good process in how to deal with these. So that's good to see. I want to talk a little bit about multiplying various ratios now. So let's see what you guys do from this. The first question, I'd say below 600, if anything. Below 600, yeah. All right, looks like, all right, you guys are doing very well. Unless you guys got this one right as well. So here's what we have. We have sugar, vanilla, eggs in a ratio of 12x to 6x to 3x. Now, the way I deal with these questions is quite literal. So when you see that the ratio of sugar to vanilla is being halved, it's 12x to 6x. So what you're doing is multiplying the actual ratio by 2. Okay, everyone with me on that? When we see that the ratio of sugar to eggs is tripled, so sugar is 12x, eggs is 3x, we're just going to multiply it by 3. That gives us 36x to 3x. Now, the key here is that we have different ratios. So we have sugar as 12x, and then we have sugar as 36x. But the cool thing is you can actually reduce this down where sugar to eggs becomes 12x to x. And now all of a sudden we have our final ratio here with the new values. So sugar to vanilla to eggs, sugar is 12x, vanilla is also 12x, eggs is x. So if the final dessert contains 4 ounces of sugar, 12x is equal to 4, x is equal to 4 over 12, which is of course 1/3. So this is 1/3. This is going to be 4. This is going to be 4. 4 plus 4 plus 4 plus 1/3 is 8 1/3. And that is your final answer. So it looks like you guys are pretty darn good at the moment with ratios, which is good. Like I said, the idea of getting things into their variable multipliers is really important. The one thing I will tell you is if you're dealing with a particular ratio question where you have ratios in your answer choices, and this goes, and we can probably stop on this question and then do a question answer. I'd say this is probably a high 600 level question. The thing with that is if your answer choices are in the form of a ratio, you can always plug in smart numbers for ratios too, just like you can plug them in for fractions, just like you can plug them in for percents. Sometimes I do it. I can't tell you exactly when I do it. I just think that if I find that by keeping them in ratio format and trying to move things around and get things in terms of different variables, I'll say to myself, okay, now's a good time to plug in, but you have to be strategic in the values you use, because if they just make things messier for you, then they don't seem to help you. A smart number is like when you're given a percent question and it says, 20% of the people, it's when you select a number that you use as your total. So a lot of times in percents, for example, we'll use a smart number of 100. So if we're saying that an item was on sale for 20% and then marked down another 15%, rather than calling the original number something like X, we'll use 100 and then we'll do the math that way. Because remember, when you have percents or fractions or ratios in your answer choices, it doesn't matter what the number is, you will get the same answer regardless. And you can mess around. If you're going through our course, you can make decisions on when to use smart numbers and when not to. I can't tell you exactly when to do it. It's a thing that you get with feel, and it's a thing that you get with what you feel like works best. And that goes with many questions. I was working with a student on remainder questions today, and it's the same deal. Sometimes you want to use the remainder formula. Sometimes you want to plug in values to get those remainders and use those values throughout. So all this stuff comes with experience and practice and getting a feel for what you personally prefer. It's problem was somewhat time consuming. I mean, I'd say it's about a 2-minute problem, but look, if you have a process and certain questions like this, and you look at this and you say, oh, this is going to be a multiplying ratio problem, the steps I took are universal. You can take these steps in any problem like this. And so, yeah, it may take you 2 minutes, but you're not going to have to think too hard to get through the question because you're going to know how to deal with it. So with this said, we can take a breather here. Do you guys have any general questions about your GMAT, about Target Test Prep, anything like that? The last question was this one here. Two questions, that's this one. When is geometry happening? I don't know, maybe a month or so. We're going through the order of the course. So perhaps next week we'll do percentages and then get into statistics, then maybe stats and probability. They're once a week. Yeah, usually the same time. I mean, give or take an hour, but yeah, in general, I usually recommend doing chapter tests on TTP, all of them. But at the same time, if you're someone who's at a high level, you can always follow the data. I mean, if you're coming to TTP and you're at a 650 and you do a couple easy chapter tests from a mission and you crush those, well, the data is saying you can move on. But if you're at a 400 level, then yeah, you should do them all. So, you know, we do give you the ability to have a little leeway there as long as you're not being careless with how you're going through the course. These are available to everybody, not just Target Test Prep students. How many ratio questions are on the real test? And I will scream this into the heavens. I welcome all you guys to read our GMAT blog on what topics, what are typical topics, or what. We wrote a blog, or I wrote a blog, about how often you may see certain questions on the GMAT. The answer is that you don't know, and you'll never know. And that's because there's only 31 quant questions, and there's a lot of major topics, around 22 major topics. Test is very random. You're never going to be able to game the test and say, I'm going to see blank of this or blank of that. The fact is, you're always going to see a smattering of topics on the test. That's just the reality. So if you want a high score, it's not about even caring of how many of what you'll see on the test. It's the fact that you'll know anything can come up on test day, and you're just going to be pretty darn prepared for it. How long do people study for? I mean, it really ranges. I mean, it can, 4 months is a good amount of time. So I would say that's a good floor, but it depends on your starting score and then, your target score and then how many hours a week you can study. So stuff like that. Any other questions? Yeah, the C version is this here. You could take a practice test from MBA.com. Yeah, we're done with practice questions. Yep. We actually have a great blog on how to get faster. I would read that. A lot of times getting faster comes with understanding how to deal with the question. Like I said in the last question we did, if you have a process, then you'll know exactly how to attack it. When we're slow, it's when we don't know how to attack the questions. I don't know if it's actually doing them in real time. Well, both of these questions are actually in our ratios chapter. So there's a more detailed version, but the short answer to this question is that because of the addition relationship, you're not going to get all your variables to cancel out. But when you have a relationship with multiplication, they do. So for example, if you have like A times C, this is very minimal, over 2A, 2 times A times C, this will cancel out and you're left with 1/2. But if you have A plus C over, I don't know. Okay, you got it. So 2 times A plus C. It's the addition that screws everything up. It's the addition that screws everything up. We don't have integrated reasoning, but I can tell you why we don't have integrated reasoning. So this is a question that's asked a decent amount. Integrated reasoning is really not its own entity on the GMAT. Yeah, it gets scored separately. I get that. But as far as what they're testing in any sort of integrated reasoning question, it's all stemming from what you've learned from quant or verbal in our course. So based on that, if you've mastered quant and verbal, especially in target test prep, all you need to do for integrated reasoning at that point is practice a bunch of questions. You can get the official problem set of IR questions from GMAT, practice those, do the ones in the MBA.com practice exams, and there's not much more you need to do. Because the fact is, there's not a ton you're going to teach someone about how to look at a graph and extract information. The hard part is, well, when they're asking about a percent or an average or a ratio, if you don't have those skills down, then IR is going to be a slog. If you do and you practice those question types, it's actually pretty straightforward. I recommend the official IR problem sets. Again, we have a blog on that, but you probably want to read it. The math is pretty similar. The verbal has some carryover. I do know there has been TTP students who have studied for the GMAT, switched to the GRE, and have been fine without having to do too much extra GRE studying, although it is very vocabulary based on the verbal side and it's not on the GMAT side. So I would recommend reading our blog on that to get more granular sense of the differences. Okay, well, if that's it, everybody, then we can sign off here. I think next week we'll probably do percents. So hopefully you guys are entrenched in the Target Test Prep course right now. If you're not, sign up for our trial, check it out. I mean, it's really awesome, and I think you'll really like it. And we'll plan to chat next Thursday at the same time. So have a safe week, everybody, and we'll talk soon.